Now, the exponential graph is something that you may have seen before, just depending on how far your stage 5 teacher took you. The equation is of the form y is equal to ax. There's nothing special about a. There are times when you might see this actually written as y is equal to b to the x. There's nothing special about a being used there. And you might see it as written as y equals c to the x. Now, this a, b and c are just various numbers. For example, over here we've got the graph of y equals 2 to the x. So a is being replaced with the number 2. We're only just really going to touch on exponential graphs briefly here. There is a very unique exponential graph, and we will talk about that. And there's a whole designated chapter just to that unique exponential, but that comes much later in the course. So for now, just know that if you graph y equals 2 to the x or a to the x, any number to the x, you will basically get this shape. Now, having said that, there are variations of this shape. So you could get at times the graph being reflected down this way. You could get the graph occurring down here, and then you could get the graph doing this. Whoops. So there are just we actually call those translations or transformations of the original standard graph. And if I haven't said it before, an exponent is just another name for an index or a power. So you will notice that the x is in the power position, in the index position, or the x is the exponent. Now, we've been categorizing our functions according to what's happening to the x. So this is just another example. We're categorizing them into this group called exponential graphs because x is actually the exponent or the power. We have a few things that we've seen before. We've seen asymptotes, so we can see that the negative x-axis becomes an asymptote because the graph gets closer and closer to it but never gets there. Not so up here. This is just the graphs going off to infinity. As x goes to plus infinity, the graph goes off, the y values go off to infinity. So yeah, we've talked about the asymptote. To get the value that goes in here, you're doing 2 to the minus 2 on your calculator, 2 to the minus 1, 2 to the power 0, 2 to the power 1, 2 to the power 2. Let's start up here. We don't need a calculator for that or that, and anything raised to the 0 power is 1, and 2 to the minus 1 is 1 over 2 to the plus 1, which is a half. 2 to the minus 2 is 1 over 2 to the plus 2, which is 1 over a quarter. So we would be graphing a quarter, a half, and that's what's being indicated here. So yes, at minus 2 it's just a quarter. At minus 1 it's still only down at a half. I might have that a bit wrong. At 0 it's on 1. Raised to the 0 power. At 1 it goes to 2, and at 2 it graphs up here at 4. So that's that graph. Now in this exercise, originally I went on to talk about the log graph because these two are paired for a very special reason. Exponential always gets paired up with logs because if we take this process called the logarithm process, then that process, what that process actually means is we're finding the power. Here x is the power, and here we're finding the power. Don't worry about this for now. Again, there's a whole chapter just on logarithms and learning from the beginning the definition of a logarithm, the graph of a log, rules and laws about logs, and we'll do our calculus of logs eventually. So for now, we've decided that we're going to leave the log function altogether, and so we're not doing the graph of it, we're not doing any of this. We put a line through all that for now, and we're skipping down to, I suppose this is a demonstration of, this is the exponential and this is the inverse, we call it the inverse. Now, graphically, the inverse is created by reflecting this y equals 2 to the x in the y equals x axis, so y equals x line. It's like a reflection. So if you folded your paper along this line, this pink would line up on the blue. I think the scales are different there. That's what's making this a little bit difficult to actually comprehend that. It's much nicer if, when you're drawing these graphs, if you have the same scale on both axes, having this much for one unit and only this much for one unit on here is really throwing this out. It's difficult to see that one is the actual inverse of the other graph. Like I said, if you didn't get any of that, it doesn't matter, because we're going to come back to all that and we're not going to do the questions on that. So I think that I would like you not to do these. I don't want you to do anything involving logs. However, you could do A, B, and I think it's E. I think it is graphing, whichever one it is that says y is equal to 1/2 to the x, and I want you to have a think about that one. Yeah, so you can cross out the ones there that I don't want you to do and replace them with B and E, which will just be about exponentials, where x is in the exponent.